Welcome back, Michael Wickerson at Wickerson Studios. This is going to be my fourth video in May of showing how to get Numpy to run some really cool numerical structures into Grasshopper to drive some interesting geometries. And you're also going to be able to move at really fast speeds because you're going to be using multidimensional arrays in Visual Studio Code with Python 3.0. It's not that hard to kind of bounce back and forth and make things work, especially if you have GitHub Copilot on. So I'm going to go down here and see what it wants to make. And it wants to create a 2D NumPy array. That's not actually what I'm going to do. I'm actually going to create, well, I guess we will, but let's be more specific, like anything with AI. And you can use ChatGPT for this to write your own scripts. I think that's a mistake to go down here. I think the best thing to do is to actually, ChatGPT is going to be free, but GitHub Copilot is just so much better, in my opinion, because it'll give you so much more accurate code, at least currently. So we're going to create a two-dimensional array from two lists. And you see it already wants to do that. We're going to write that into a ghops component because as you write these apps, they write themselves. They kind of predict what you want to do, and you find you're kind of a co-pilot to the co-pilot. You're the one that's assisting the computer. The computer's just trying to do your work for you. So let's see what happens when we write this hops. We're going to make a NumPy array, and we'll call it a 2D array. I didn't mean to do that. Step through it. If I want to change anything, I'll just go back and fine tune it. I don't mind it being a NumPy 2D array, but from two lists. It'll give you a name, it'll give you a description, it'll give you inputs without the icon. If it does give you icon, just go back and make it say inputs. We're going to bring in a list hops number, and we're going to say that's item index. Perhaps we're going to try this a little different with list access. Let's see if this makes a little difference in our script. So step through that. We're going to bring in a list 2. And because there's no comma here, we can kind of predict that GitHub Copilot wants to end the inputs, which is fine with me. And the outputs, we're going to pull it out into an array of values as a list. Now there is an issue here as we start to do this. And there's something I want to bring up here before we write the definition, creating those lists. I want to go back into our other file and show you that what I've done is I've specifically put this data in pretty regularly. Let's see where it is. I don't think I was using it yet on this script. So let me go farther down and open one of these other scripts that I had available. The NumPy master. Let me see where I had it. I think I had it because I erased a lot of this stuff. I thought it would be here. Let me just think here a second. I have so much on my desktop that I'm kind of racking my brain for. I thought it was actually here. Source files. Oh no, that's the GH master. That's not what I want. Date modified. Let's go back to date modified. There's our master scripts. Oh no. I've lost my mind. NumPy master scripts. We'll jump into one of these where I actually started to use. Let's go down to analysis and open that one up. Let's give that a second to load. And you're going to see that I have some information about dealing with. And I did this later, and you have to think that I've written this once, solved a lot of the bugs, but I'm going back and writing it from scratch with you. So I want to fix things as we go. So just give this a little bit of a moment. I think it's loading up. Where I was with Python for data analysis, the third GH script. And what's happening is you'll see that I had input items coming. I was outputting as I wasn't specifying the hops RAM access. And I think the more accurate you get early on, the better. And in here, I had some for arrays, and that was my problem. I was using for loops for I an array. I was appending lists, and that was slowing down my script. So I don't want to make that mistake again. Let me just cut and paste what I'm talking about. Because I wasn't trying to get around this, I'm just going to cut and paste this in here for a second. So the definition I had was trying to set up a list, and then it was trying to output the array, and then it was trying to bring that array back into a list using for loops. That's not really using the power of what NumPy does. So we're really not going to mess around with that at all. We're going to go into here, and as soon as we can get this latest script plugged in, it's taking a little bit of time. Not sure why it's taking so long to open a script. There it is. This is one coming farther along. You can see that these scripts get more elaborate as we go. But here, I'm hoping I started to make the adjustment, and I thought I did, and I did not. I did not go farther down the pipe. So we're going to take that one and shut that one off, and we're going to try this one more time. I'm going to file open, and let's just go right to the last one because I know 100% that that one had the data that I needed. And I think that's a smaller script, so it should open up pretty fast. So just bear with me here a moment on the video, and this is kind of things that I figured out for you. I'm sure there's people like Niels that figured this out a lot more, and they're not making such simple little tiny scripts. They're probably using the Rhino 3DM a lot more up here when they're importing Rhino 3DM. I imagine they're doing a lot of geometries in these scripts. I'll just stress again, I'm not interested in that. For NumPy and controlling a lot of data through multidimensional arrays, I think the key is to just output numbers. Floats and integers, possible booleans, and you will have to get in the series when you get into data frames with pandas. And that's just what I believe. So what I have here is here's an example of how I'd set up a script. But let's go here and take a look at the full file. So everything has this kind of specific information, what it does, but it gives you this warning. Print AR list to tree not working in Grasshopper canvas. Use entwine in code. So it gets a little sloppy and you have to predict your outputs, which does limit when you're looking at making multidimensional arrays, how many rows you can bring in, but you can bring in as many columns as you want. But the same warning on every one. So you have to return this array to list, but you have to be specific to which list within the array you're specifying. So I'm just going to grab that script there, and I think what I'm going to grab is one that's closer to where I need it. Actually, I think we're over here, so we can just grab that one. I'm going to cut it, and when you copy from one script and come back over to the other one you had, which is right here, and you paste it back in, it's going to pop pretty much back in where it was on that old script. That's something people don't know too well, but I'm going to start bringing this in and showing you that that is important information. So it may not look exactly like this, and you will have to use the entwine node, but that's a warning that I want to start putting into everything we do. So I'm going to save this one. I'm actually going to save it up here because we're starting to think of it. I'm going to grab this function here, which I've got some visuals that aren't actually needed, but there is an entwine in there, and I've got a list to start. I'm going to copy and paste, and I'm going to drag that down here. And I'm going to talk about this being a NumPy array, a multidimensional array, and we're going to call this the NumPy array, and we don't need to say that anymore. Well, I guess we could. Let's call it a two-dimensional array from two lists. Right, that should be good enough to start. That's what it is. And then here's our warning about dealing with arrays back in our function. And I might go in here and just give a little warning as we go into this. I might do it at the end, but I might slip it in here just as a little warning for now. Print array list to tree not working in Grasshopper canvas. All right, and I'm also going to say use entwine to convert use entwine in Grasshopper to convert tree to list, and then we're also going to say return AR to list. You can do it this way, and there's another way to do it as well, but we'll just do this one to list and you have to specify which array is it going to. So that's if you want the one list or not. And we'll just leave it at that, and then you'll see how this works differently. So hopefully when I get into this, I'm not going to make the list. I want to write the array into a list, print the array, print the type of array, then do the array to a list, and then return the array. And let's see what it looks like first. And we're probably going to have to change this array 0 and array 1. I think there'll be 2, and we'll have to go back up here and we'll have to add. So I'm fixing from what I did before, and there's the array, another array 2. So what I may do is go in here and say array 1, there we go, to list, and array 2 to list, and that should be enough. Now if we get lucky, we should be able to output 2 arrays back out of that, and then we can entwine them back together. So that's a better way to write it besides going in and writing it this way. And I'm not sure if it's going to work. I might have to check it out, check my commas and my square parentheses, but that's the way. That's not the way you want to write it, which will work, and it writes it out as a single list, but you're not going to keep your lists as separate lists, and you're going to kill your tree data. That's going to kill the data tree. So don't use this. And maybe I will go quote, 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 just because this is our first one. Oops. Do not, and I'm just going to make sure this is hashtag in case I get in trouble. Do not use this structure because it will destroy your tree structure, your data tree information. And so that might make sense. And let's close this out here with closing the parentheses. And there we go. I think that'll work. That'll stay in comments. So that's just something to start. Let's see if we get lucky with a save and a paste. Everything running, hopefully. Grab our internet protocol. We're going to get rid of this one. And we're going to have 2 lists here, which should be fun. I'm going to maybe kill this information here because it's not needed right now. I'm not sure if I want to do any of that visualization. We'll decide what to do with data visualization when we're done. I'm just going to keep things very geometric and simple, kind of like when I was doing Euclid's geometries. Triangles and circles and points and lines are good. If you can keep your information to numerical data and points and vectors, you should be able to move your geometries incredibly fast in Grasshopper, and that's something that Peter Davis and I have talked about. I think he's a genius for pointing that out. This will have 2 structures, and we want to maintain those 2 structures when they come out, and hopefully we'll get around this with the entwine. So with any luck, we can grab down a hops node and watch it bug out on me, but that's always fun because we can show how to debug. And we're going to go back up here to the top of the NumPy 2D array, paste that in, we're going to hit it, and hopefully we get the first list, we hit the second list, it's running. You'll see you get your top 3, you'll see that you get your bottom 3, and if you want to see that as an entwined list, that's where the entwine node comes in, and I would recommend using it. An entwine is like merge, but I just don't use it anymore, and I learned that in kind of robotics workshop. There's no point to that. You can come in here and you can get rid of this one in the end, and now you have your 2 bits of data that maintain their data structures, and you can put them into the same node. And now you can start thinking about, how am I going to drive that data? How am I going to use that data to drive geometry? So if I grab both these circles as the x-coordinate and both these as the radius, we should be able to see what kind of geometries we're pulling up. And there you go. You have an even more exciting geometry as you move through. And what I would say in the process is left click, grab the name of your function, numpy2 from 2 functions. We're going to fix every single one of these this way. And we're going to right click and change the hops name because we do not need icons. If anybody wants to work for free for me and make beautiful icons for all these NumPy things, that would be such a job for somebody that loves to make icons, which not me. And then we're going to go up here and we're going to grab what we need to list that. And it's good to be playing with around this enough that if you are having trouble with bugs, you can kind of decipher what they would be. So you get some really nice geometry that's jazzed up from this geometry, which is jazzed up from the geometry before. And we're just going to keep visualizing these kind of circles on top of each other as they become more complex. So single information, double information, and now tree information, which is pretty sweet. And that's enough to have for this little video. So I'm going to fix each one. We're going to create a 3D dimensional array from 3 lists after this. And you're going to see this slowly advance and become more exciting and thrilling. And you should be really excited about that. And I think I'll just pull this over for now just to make this look a little interesting. And there you go. And maybe make it so you can see our Numpy and our visualizations. I do want to have this on, hopefully there, not too exciting. And we'll just take a little screenshot just to advertise, but there's no point in doing that now. I'll just leave that in a minute. All right, so we're going to stop recording